Today we're going to look at calculations involving energy and/or power. This is for the NPA Science and Technology course or the N4 Physics course. The video aim. Well, by the end of watching this video, you should be able to state the definition of power in the context of electricity and appliances, be able to draw the power-energy triangle, and be able to use the triangle to solve questions related to energy and power measured over a period of time. So what is power? When talking about electricity and electrical devices, power is the amount of energy transferred per unit of time, which is per second. So in other words, power is equal to energy divided by time. Power has the units of watts, energy has the units of joules, and time has the units of seconds. And as you can see here on the right, we have a calculation triangle where if you remember it, and I thoroughly recommend that you do remember it and draw it every single time, then power has to be in watts, energy has to be in joules, and time has to be in seconds, and it's very useful for solving all problems. So let's look at example question 1. An electric kettle transforms 180,000 joules of electrical energy into heat energy and sound energy in a time of 120 seconds. Calculate the power of the triangle. So this is how I would advise you perform this calculation. First step is you would draw down the calculation triangle, the power triangle in this case. So draw down your triangle and try and remember this relationship. Now power is the amount of energy that's used over a period of time. So if you think about it, power is equal to energy over time, just the way that I said it there. So power is going to be equal to energy divided by time. Okay? Now all you need to do now is look for the information in the paragraph and substitute those values into the equation. So we have the electrical energy here. So we can change the E into 180,000, and we have the time of 120 seconds. So we could divide that by 120 seconds. And when you do so, you get 1,500 watts. And that's how you answer that type of question. Now, what's important is you should watch out for units. Sometimes power will be in kilowatts and time will be in hours. You will need to convert 2 watts and seconds to use the equation. So you know the relationship between kilowatts and watts, 1 kilowatt is equal to 1,000 watts. So if you use that statement there, that should help you to understand the conversion of watts into kilowatts and kilowatts into watts. Basically, if you have kilowatts and you want to convert it into watts, you times by 1,000. Okay, and if you've got watts and you wanted to turn it into kilowatts, then you would do the opposite. You would divide by 1,000. We will not likely be using that. We are more likely to be using the multiplying by 1,000 technique. So example question 2. The power rating of a washing machine is 0.5 kilowatts and a cycle takes 1 hour to complete. Calculate the energy transferred. Well, you should draw down your power triangle. Power is the energy that's transferred over a period of time. So power is equal to energy divided by time. But in this question, we are actually being asked to calculate the energy. So really, this equation has energy as the subject, so it's going to be power times time. The power is 0.5 kilowatts, so we need to convert that into watts, and we do that by timesing it by 1,000. So if we take 0.5 and times it by 1,000, we get 500. And we have time in an hour, and we need to convert that into seconds, and so therefore 1 hour is equal to 60 minutes. And there is a 60 seconds in a minute. So what we need to do then is we need to take the hour, multiply it by 60 to get the number of minutes, and then we need to multiply the 60 by another 60, and that would give us the number of seconds. So this could be changed into 3,600 seconds. Right, now we need to take this value here, the 500 watts, and the 3,600 seconds, and substitute them into the equation. So power is 500, and the time is 3,600 seconds. And if we multiply those together, we get energy is equal to 1,800,000 joules. So this here is our answer. Now I suppose you could convert that into millijoules, which would be 1.8 millijoules of energy. Now I'm going to ask you to try the questions provided on the worksheet. This will be on Microsoft Teams, and if I find a way of hosting that worksheet and providing it in a different way, I'll add that into the description at a later date. Try your best and see how you get on.